What's up guys, welcome to the 18th tutorial in our Pandas course. Now that we're familiar with fetching elements and properties of data frames, let's talk about modifying our data frames. The simplest modifications will just be add, remove, insert, and interchange operations, so we'll study those here. We'll start just by modifying data frame elements. So we'll be picking individual elements in a data frame and changing them to different values. Then we can talk about modifying entire columns and rows in a data frame. We'll also focus on shuffling and relabeling data frames, or just generally changing the structure of data frames. This is all very similar to what we did with the series. Now, there's a lot of stuff to cover here, so in this particular tutorial, we're actually just going to study adding elements to data frames and removing elements from data frames. In the next section, we'll continue on with the first 3 points there. That'll be the modification of individual elements, columns or rows, or just shuffling and restructuring data frames. So let's head on over to the code and get started. Right, last time we left off in section 17 by learning how to fetch various data frame properties, stuff like count, maximum, minimum, the n largest, index of the max, etc. Okay, so let's get a new row started. And again, make sure you've got your pandas import ready to go. Otherwise, we can go ahead and actually just copy over a couple of data frames. So I think I'm going to choose the same data frame from before. Okay. Doesn't really matter exactly which figures and numbers you're using. I would recommend something like at least 3 columns and at least 3 rows, although no hard and fast rule about that. I'm actually going to duplicate this and create 2 data frames. And this is because at some point we're also going to introduce combination functionality as well. So I'm going to call this df1 and df2, and I'm just going to modify the structure a little bit. I'll get the same row and column structures, but I'm just going to change up the values. So let's do like 10, 6, and 9, and actually I'm going to change this to row 4. I'm going to change this one to row 2, and I'm going to say that this is going to be a 2, a 1, and let's keep that one as 6. And then column 3 will have rows let's say 3, 2, and 4. That's fine. And then we'll do, I don't know, like a 7, 6, and a 0. Okay, just as long as we have some variety between the two, not necessarily a requirement, but would help to demonstrate some of the points. And this is what our data frames are going to look like, just for your reference here. We've got data frame 1 and data frame 2. Okay, so again, both have 4 rows. This one's kind of a bit messed up, so we might have to change the order, but no problems really. Then we have column 1, 2, and 3. Okay, we've got numbers in different spots. We've got some slightly different values. Right, cool. So I would like to actually keep those both up there. So as per usual, I'm just going to print out my dotted line underneath. And that way we can kind of reference the data frames and any functionality that we're currently working on. Okay, so the first thing that we're going to cover here will be adding elements to data frames. Now, there's 2 main ways to do this. One is to just assign a row or a column that doesn't exist already. The other way is to use the append function. So the way in which we just assign a new column or row is very, very simple. It actually works exactly like a regular Python dictionary. So with a regular Python dictionary, when we assign a new key some value, if that key exists, it just replaces whatever value is currently there. If that key doesn't exist, it actually inserts a new key and then assigns a value. Well, the functionality here is exactly the same as that, at least when we're dealing with columns, and actually we'll find that it's the same as rows, but a little bit more restrictive. So what we're going to do is we'll just add a column onto data frame 1. So we'll do df_1, and we'll add a column that doesn't exist. Col4 doesn't exist, so we'll do data frame 1 of column 4 is equal to, and then some values. Now, the simplest way is just to pass in a list of values. For example, 1, 2, 3, and 4. It's probably better practice to have them be of the same length. Otherwise, if you try to add more elements than there are, it may end up either cutting them off or filling them in with not a numbers. So actually the same thing will happen if I were to do something like this. If I were to assign a pandas series, okay, and I tried to assign actually a dictionary with different labels. So for example, let's say I did A of 1, B of 2, C of 3, etc. This is actually just going to create a new column, but fill it with not a numbers, because we already have the structure built up. And this is trying to insert a bunch of stuff that doesn't exist. So essentially, this will try to find a row called A and insert a number, try to find a row called B and insert another number, and so on and so forth. However, those don't actually already exist within the data frame, so for some reason this doesn't insert them, and this is basically not really going to do a whole lot for us. Okay, I'm just going to comment that out and make a note afterwards. This, however, will just add a new column onto the end of our data frame 1, and it will contain these numbers. So we can go ahead and print out data frame 1 just to see the end results there. Okay, let's go ahead and run it. All right, good stuff. So we get col 1, 2, 3, and 4. Note how these are all integers, clearly a different data type from the others. Again, that's perfectly allowed. We can have multiple data types in a data frame. Also, note how this is data frame 1 that I'm printing. That means this is modifying the original data frame rather than creating a new one. Okay, almost all of these operations in which we're fetching stuff or modifying stuff have been operations that return new data frame. This one actually modifies the original one. That's very important to note. Okay, next up, we'll talk about inserting rows into a data frame. Now, when we insert rows, it's very, very important that we have the same number of elements as we have columns. Okay, so we can still do that. That's no problem. We could do, for example, df1 of some row that doesn't exist. So let's say .iloc. No, let's not do iloc. Let's do .loc. Okay, and we'll add in a new row. Let's say row 5 doesn't exist. So let's add in row 5. And we're just going to set this equal to some new numbers. So we'll do, I don't know, 20, 30, and 40. Note how I'm still adding a list, but I need 3 elements because, oh, actually I need 4 elements because we have another column here. So 50, 20, 30, 40, 50. And I need the same number of elements as I have columns. So we can run this again, all right? And it works out just fine. There's no problems there. Still adding the items, but we need 1 element for each column that exists when we're inserting rows. All right, so the next way we can add stuff is going to be using the append function. Okay, so that is going to be, I don't want to run that. What we're going to do is we're just going to say df_1, and actually I'm just going to copy this over, say this isn't allowed. Okay, so df1, and we're going to call the append function here. Okay, and then we can just pass in, typically it's a data frame of some sort or a series. Okay, we'll just do, this should be, oh, getting these kind of mixed up. Okay, data frame 1.append, and then let's add in a new series. So we'll just do a pandas series, okay? And we can, because we're just going to be adding in basically a new row, we're just going to need to add in as many elements as we have columns again. So for columns, make sure there are 4 elements here. So we'll just do, I don't know, 11, 12, 13, and 14. Okay, and we'll go ahead and just print that out. Okay, we're getting a problem here. Ignore index of true. Okay. So in this case, we actually need to set ignore index equal to true. So under the append function, ignore index equal to true. Okay, so this basically just ignores the index labels that we've assigned here. The reason we have to include this is because we're trying to enter these items which would actually have the index labels of 0, 1, 2, and 3. However, if we had had this, the same index labels as we have columns, so col 1, col 2, col 3, and col 4, that would not have been a problem. And actually, this has not been changed. Oh, okay, because we need to return it and store it back into this. Okay, and then we'll just go ahead and print that out. Okay, there we go. Good stuff. So now we have a big mess on our hands. Essentially, instead of just inserting the rows at the bottom like we wanted to, what we're doing here is we are inserting the rows, but we're trying to use their original indexes. So it's created a whole new set of columns. We don't really want that though. What we essentially want is the same column labels. So I can just pass in my index label here, and that should be no problem. So we're just going to take col 1, col 2, col 3, and col 4. Okay. And we can go ahead and run this. And there we go, that fixes the problem right away. Okay, so typically you do want to make sure that the data you're entering in is going to match the data that is already in the data frame, unless of course you wanted that effect that we saw just a couple seconds ago. All right, well, that was quite a lot. Let's quickly cover combining, and then we can go into removing, and then we'll call it quits on this section. So I'm actually going to comment these guys out, okay, just because I don't want to modify these original data frames. I want to leave them as they are for the upcoming operations. Okay, so the combining is essentially going to take 1 and stick it onto the end if we use a concat operation, or if we just use the combine first function. This actually combines the two, but it will overwrite anything that it needs to. Now, luckily, both of these operations actually return new data frames, so we can leave the original ones intact. So I'm just going to create a variable called combined, and I'll show you what I mean. So we're going to do df1.combine first with df2, df_2. Okay, and then we'll just go ahead and print out combined. So remember, this is going to leave the original data frame untouched. Okay, so it will just return a new data frame with the operation performed. Okay, so maybe not quite what we were expecting. And that's because we are using the combine operation, which is not just sticking a data frame onto the end of the other. That's going to be the concat, which we'll study in just a minute here. This one is actually going to essentially overwrite everything from data frame 2 with data frame 1, unless it's not a number. Okay, so for example, the remaining, this data frame here, column 1 has 1, 1, and then 3, and then 6. Well, the column 1 for data frame 1 has 1, 1, and 3, but the row 4 has not a number. However, the row 4 in the second data frame has a value of 6, so it basically overwrites that. So essentially what we're doing here is we're overwriting anything that overlaps from data frame 2 with data frame 1. So if there's any overlap between row and column values, it will overwrite whatever's here with whatever's here. Okay. The only time that it doesn't overwrite anything is if there is not a number. And so we saw, for example, in col 1, row 4, there's not a number here. So we find the col 1, row 4 in the next data frame. As long as it's not a number, it will overwrite that not a number. Otherwise, it gets overwritten. On the other hand, if we use a concat function, that will just take one data frame and stick it onto the end of another. So I'll just call this combined again. It's going to be equal to a pandas.concat function. So it's actually not taking the one data frame and then combining it with another. We're using the pandas concat, and then we have to pass in the data frames that we want. So in this case, we'll just use df1 and df2. Okay, and we'll just go ahead and run that. Okay, and let's see what the problem is here. Oh, this should be in, this should be in a list like this. So we basically just put all the list in order of everything that we want to concatenate together. Okay, here we go. So this is literally just taking one data frame and sticking it onto the end of another. Now two things to note actually. First of all is that we have duplicate row labels. That is actually the desired behavior with this, and that's totally allowed. There's no problems there. That just means whenever we fetch a row, it will probably fetch multiple rows. For example, let's say I wanted to print combined, and then I want to print combined at the row, so lock off at row 2. Okay, going to go ahead and run that. You can see that this is actually printing me out 2 rows, because there are 2 rows with the label row 2, 1 and 2 here. Okay, so you will probably get multiple or duplicate row labels. So just make sure that you're aware of that before using this function. Otherwise, again, it will stick this onto the end of the first one, and it will continue to do this for as many data frames as we have. We can concatenate multiple data frames. We can also concatenate data frame slices. For example, let's say I only wanted the first couple rows. I could do this. Okay, same with this. And we can basically just keep doing that, all right? Again, it's important to note that this will return a new data frame rather than modifying the original one. Okay, so finally we'll talk about remove operations. These are very, very similar to the series remove operations, but of course we have multiple axes to deal with. There's 4 things I want to cover. The first is going to be the drop NA function. So essentially this is going to be df.drop NA. Okay, note how it should take in an axis as well. This allows us to drop either rows with NAs in our data frame, or columns with NAs in our data frame. This also returns a new data frame, so I'm going to call this something like dropped is equal to this. We no longer need to print those. So we'll say dropped is equal to df.drop_na. Okay, and we're going to go ahead and print out drops there. Okay, so we don't really get a whole lot because there are 3 out of 4 rows here. And this is data frame, that's actually our old data frame. Let's do dataframe1.drop_na. Okay, yeah, so we actually only get the 1 row, and that's because there are 3 rows here with not a numbers in them. So it just cuts out the entire row and returns the result. So it doesn't modify the original data frame. If I said axis equal to 1, okay, this is going to drop me the columns with not a numbers. Unfortunately, all 3 columns have a not a number in there somewhere. So this is going to return us an empty data frame. Okay. Now, if we want to drop specific columns or indexes, we can use a df1.drop function. So the drop function will allow us to specify which labels or which indexes and columns or labels or axes that we want. Okay, so for example, let's say we want to drop a specific row and a specific column. Let's say I wanted to drop row 4 and I wanted to drop column 3. What I could do is I could specify in my rows section, there's actually index section, specify the rows that I want to drop. So in this case, we'll just do row 4. And columns, we'll do the column names. In this case, this will be, let's just say col 3 that I want to drop. Okay, this is again going to actually return me a new data frame. It's not going to change the original one. So I'm just going to store this back into dropped, and we can go ahead and run that. So now you can see it's basically returned a new data frame just with that column gone and that particular row gone as well. Okay, so this is probably the best way of doing things because you get a new data frame and it's very controlled as to exactly which columns and rows you're dropping. Alternatively, we can use the delete function, the delete df, and then whatever column we want, so let's say col 2. Keep in mind that this will modify the original data frame and we can only use this with columns. So let's say I want to delete column 2 from data frame 1. Well, if I print out data frame 1 now, this is going to return me that with that column completely dropped. Okay. Similarly, if I use this pop method, so if I do like df1.pop, okay, and then the column name, let's just say column 1 we want to drop, this is going to modify the original data frame. It will change data frame 1. This, however, will also return the popped element. So I can call this popped is equal to this. And I can just print out, I guess I'll print out popped and then I'll print out my data frame. So popped like so. All right, so this is, you can see that column 1 is now removed. And I'm also returning that column in the form of popped. So printing out popped first. This is a series, and it's essentially just whatever column I popped with all the rows and the values. It's got the name, data type, and then finally the data frame only contains column 3. Okay, so I know that was a lot that we went over. This was a really long section. So let's just do a quick recap of everything. And as per usual, I'll leave some comments and some notes. So we just created a couple data frames. They were the same in structure, but just slightly different figures. We worked on adding elements to data frames. So we can add an entire row, or entire column rather, just by specifying a column that doesn't exist yet, and then assigning the values. We can also assign a series to the same thing, but we should probably keep the labels the same. We can add in a row by using the dataframe.lock, and then the row label, as if it doesn't exist, then it will assign new values, but we need to make sure that we have the same number of elements here as we have columns. We can also use the dataframe.append function to add a series or some kind of list-like structure onto the end of a data frame, but again, probably best to keep the same column labels and the same number of elements, otherwise you'll run into trouble there. Next, we learned how to combine data frames. One was a way to just kind of overwrite the second one, and the other way was just to stick one data frame directly onto the bottom of the original one. Keep in mind again that this will duplicate indexes if there are the same row indexes between data frames. Finally, we covered how to remove elements from data frames. We learned how to use the drop NA. That's going to be used to drop any rows with not a number. Or we can do the same with columns. Okay, depends how we specify our axis. We can also use the drop function to drop specific rows or specific columns by passing in the labels. We can use the delete function to drop only columns. we can use the popped function to remove a specific column and return it. Keep in mind the delete function and this pop function do modify the original data frame, so that will, you will have to face those repercussions. Okay, otherwise that's it for now. When we come back, we're going to be working on the other modifications. This will be typically reassigning values or restructuring data frames. So stay tuned for that. Thanks for watching and see you guys in the next one. Hello everyone, welcome to the 19th tutorial in our Pandas course. Here we're going to continue on with data frame modification. In the previous section, we started by talking about adding elements to data frames and removing elements from them. Now we're going to work more on the modification or the restructuring side of things. So this will be modifying individual elements, columns or rows, or shuffling and relabeling our data frames. So let's head on back to the code and begin. Right, so previously we finished in section 18 by talking about adding, combining, and removing with data frames. This was a really long one, and we covered a lot of material. So now we're just going to finish off with the modification functions. A lot of them will use similar-ish functionality, but we'll also be talking about restructuring as well. So the first thing we want to do is get a cell started. Again, of course, make sure your IPYMB notebook is running, and you also have the necessary imports and everything. So I'm actually just going to copy this, I'm just going to copy this whole thing here. And I'm going to get rid of data frame 2. I don't need that, but I do want data frame 1. And I'm just going to rename it to just regular DF like so. Okay, so just as a quick reference, this is what it looks like. You don't have to use this specific one. Just as long as you have a few rows and columns to work with, it'll help to really solidify some of the points. Okay, cool stuff. Now, let's talk about the reassignment operations first, so reassigning entire columns, rows, or just individual elements. It's actually pretty easy to reassign a column. We know how to do that already, and actually the same with rows. So we can use the same functionality that we've seen previously to reassign values as well as to add new values in. Again, much like a dictionary, a regular Python dictionary that is, if the key exists, it reassigns the value to it. If the key doesn't exist, then it just inserts the key and then assigns a value. There are some restrictions, however. We have to make sure that these items are of the same length and structure as our data frame already. So for example, let's say I wanted to modify my first column here. I get my data frame, and I'm going to specify column 1, and then I'm just going to reassign some new values. Okay, so I'll start off just using a basic list. We'll just do something like 2, 3, 4, and 5. Okay, then we can go ahead and print out what our data frame would look like with the modification. Okay, so fairly straightforward. It's really just reassign the values there. You can also note how there are no longer any not and numbers, so we can resort back to the simpler integer type rather than using floats. Okay, if I even added a single float in there, however, it turns a whole thing into floats. There are the restrictions in that this has to be of the same length as this series already is. And so, for example, I can't then add some more items into it. Okay, that's going to give me an error right away, as the length of values does not match the length of the index. Similarly, I cannot add fewer values. That's also going to give me an error. Okay. I can also reassign a whole series. So, for example, I can say df col1 is going to be equal to a pandas series like so. Now, probably the easiest way to do this is just to pass in a dictionary kind of like this. That way you can explicitly assign the row labels correctly as well as the values. However, if we were to do some incorrect labels, so let's just copy and paste that in, but I'm going to take away the rows. So we are essentially using different values. I'll just do 1, 2, 3, and actually there should be, we should have a fourth in there as well. Let's just do the value of 4. Okay. This is still going to kind of add them, but not really. Essentially, we're just filling in these with not and numbers because our data frame doesn't already contain these indexes. If we want these to be properly represented in the data frame, we really should pass in the correct labels. So I'm just going to enter in the rows back there, 2, 3, and 4, and that should nicely reassign the values into their correct place. Okay, so that is how you'd reassign columns one at a time. Now, what about reassigning rows? Well, we can actually use again the same functionality here. Just specify the row index or the row location. because we know what the row location is, we should probably use df.lock as much as possible. That just kind of communicates your intent a little better. Besides, if things get shuffled in the data frame, you might end up accessing the wrong index, and it just becomes kind of a mess. Of course, it's not always the case that we know exactly what the column label is or the row label is, but as much as possible, try to use lock rather than ilock. Okay, so we're just going to specify this will be df.lock, and we'll specify the row that we want. Doesn't really matter which one we're replacing here. Let's just do row number 1. Okay, so we'll do row 1. And we're just going to reassign this to something else. Now again, this could be a list of values. It could be a series. So let's say we want to change this to 10, 11, and 12. Okay, and then see what our data frame looks like. Well, that's totally fine. Again, 10, 11, 12. And weirdly enough, it leaves 10 as an integer, but 11 and 12 get converted to floats. Okay, and that's again because the data type is column specific, not data frame or row specific. Okay, so this gets fitted into the first column, which is just integers, so it remains as an integer, but 11 and 12 are stuck into float series, or float columns, so they have to change to floats as well. So just like before, we really should be assigning the same number of values. For example, let's say I try to add 13. That's also not going to work because, again, we're basically trying to restructure the data frame and it doesn't want that. There's special operations that will help us to do that. So we need to make sure that we have the same number of elements as we have columns. Once more, you can also assign a whole series to it. So let's say, actually, you know what, I'll just do it by hand manually again. So we're just going to reassign row 1 equal to a pandas series. Okay, and let's take a look at what will happen if we try to assign a series with a bunch of index labels that don't exist. So let's say we try to do something like this. We're basically creating some columns, some new columns. I'm actually just going to say 1, 2, and 3 there. Okay, and we'll try to print that out. Okay, so this actually does the exact same thing as when we tried to do that with rows. If we try to assign labels that don't exist, it's still going to add the row, but it will just replace it with not a numbers instead because it can't really recognize these indexes. So in that case, we do need to again pass in the correct index label, or correct column label in this case. Okay, and otherwise that should be totally fine there. Okay, there we go. Good stuff. So we get our nice values put back into the data frame. Now, before we get to the restructuring of data frames, there's one last thing I want to point out, which is a really, really useful function, by the way, especially if you're trying to perform a lot of numerical computations on data frames that might contain not a numbers, because of course we don't want those skewing the data. There is actually a function that will help us to replace all of the not a numbers in a data frame. We can see that after all of these operations, we still have 2 not a numbers in there. So we can actually take our data frame and we can call upon the function fillNA. Okay. Now fillNA will take, I guess, a few different labels. If we just specify the value and not the axis, that's going to do it across the entire data frame. If we specify the axis, then it will only do it specifically in a row or a column, depending on which axis we're doing. Okay, so in this case, we're just going to fill in the value maybe of 0. Okay, so that way at least we have some numbers rather than these annoying not a numbers. This is actually going to return a new data frame, so we're just going to reassign that back into the original data frame. We can go ahead and run that, and you can see that all of the not a numbers are now filled in with 0. So super useful stuff there. Okay, so that is pretty much it for reassigning. So reassigning values. Now let's talk about restructuring. Okay, so we can restructure based on columns, based on rows, or both, of course. And we can also use the reindex function to assign new columns or new rows to the data frame. So let's take a look at adding new columns first, because again, data frames are typically column specific. So let's say we want to, actually let's talk about shuffling first, and then we can talk about adding new columns. We can shuffle things using the reindex function, and that actually returns a new data frame. So we're going to do something like df.reindex. Okay, and reindex I think we've actually used with series as well. This time you'll note that there is an axis, there is an axis parameter in there as well. It will also allow us to take in indexes, columns, okay, and a few other things such as methods if you want to do things according to a method, and if you want to fill not numbers, and so on and so forth. Now, generally speaking, if we're going to just perform the labels, it will be a column-specific reindex. Or no, it's actually the other way around. If we were to just fill in the labels, usually it's a row-specific index. If we want to reindex our columns, then we have to add the axis of 1. Okay, so this is one of the few functions that is row-specific, but it does work that way. Okay, just because typically when we talk about data frames, when we use the word index, we're actually talking about the row labels. And then when we use the word columns, we're talking about the column labels. Okay, now we're going to be a bit more specific by talking specifically about the index and columns. That way there's really no confusion there. So let's say again we want to change our columns. Okay, we're just going to pass in a list here, and then we can basically shuffle the columns or add in new columns. So let's say I want to do things in reverse. I want column 3, then 2, then 1. Okay, I can do col 3, col 2, and then col 1. Okay, again this returns a new data frame, so let's just call this something like restructured. It's going to be equal to this, okay, and I'm going to use that. Okay, so let's go ahead and run that, and this is being a bit slow, but there we go. So essentially it's just kind of taking our columns, keeping the same row order, but just shifting them around. Now I can also add in new columns this way. And so for example, let's say I want to keep the same order, 1, 2, and then 3, but I want to add in a 4th column. Okay, so I'm going to add column 4 here. What this will do is it will actually create that new column, and it will fill in the values with not a number. So that's kind of like what we were trying to do when we were, let's see, adding columns in like this. I guess this is actually explicitly adding in the column and filling values. This is kind of like if we were to try to reassign a column with more values than there actually are. Okay. This way we can actually create the new column, but it will fill it in with not a numbers. So probably if you want to just add in one column at a time, it might be better to do something like this with the new column label. That way you're not stuck with a bunch of not a numbers. Now once again, keep in mind that this is not modifying the original data frame, it's returning a new one. Okay, so the original data frame will have the basic 1, 2, and 3 columns. Okay, so actually on that note, we can also change the column labels simply by reassigning them into the columns. This one will modify the original data frame, keep in mind. So let's say I wanted to change my data frame columns to, maybe I want to just change them to the labels 1, 2, and 3, like so. Okay, all I need to do is assign that list of new values back into my data frame columns, then I can go ahead and print out my data frame. Okay, so there we go, it's just reassigning them. Once again, make sure that you have one value for each of your columns and it will match them up according to their positional index. So for example, it knows that there's going to be the first column at index 0 is going to take on this value, column index 1, index 2, and so on and so forth. So that's basically restructuring according to columns. Let's talk about restructuring according to rows. We can follow pretty much exactly the same principles by talking about using the reindex function, or if we want to relabel things, we can also do the df.index. Okay, so we're going to, I guess we can actually just copy this and paste it over. And instead of working with the columns now, I'm going to work with the index values. Okay, so we have row 1, 2, 3, and 4 right now. Let's reverse it. So we can do row 4, row 3, and row 2, and row 1. Okay, cool stuff. Okay, then we want to go ahead and print that out. And this will essentially have our original data frame, but just with the order reversed. So 4, 3, 2, and then 1. Similarly, we can also add a row, just like before with the columns. Okay, so we're going to just change these. Let's do 4, 3, 2, 1, and then 0 down at the bottom. Okay, and this should work in exactly the same way as with columns. It will just create that row and fill it in with not a numbers. So once again, if you're just adding one single row, probably best to add it like this, but just reassign some actual values into it. This is better if you're adding multiple rows, and then you'll fill them in with values later on, because otherwise you'll end up with a ton of not a numbers, and that's not good. Okay, we can also reassign the indexes, so df.index. Okay, is going to be equal to some new values. Keep in mind again that this is modifying the original data frame rather than returning a new one. So again, let's just change those labels to, we won't do 1, 2, and 3 because that's what we're using for our columns. Let's just do R1, R2, R3, and R4. Okay, so we'll do R1. Oops, didn't mean to return there. R3 and then R4. Okay, and then we're just going to print out the original data frame. Okay, so again, exactly the same operation here. It's really just a way to relabel things according to their positional index. Once more, we do have to provide one value for each of the labels here, otherwise it's going to throw us errors. Alright, so I think that's pretty much all I wanted to cover. We got another long one again, so I do apologize for kind of going over, but there is just so much to talk about and I have to kind of explain all these little bits that may be unexpected if you haven't been exposed to these functions before. Okay, so just to really quickly recap, we copied over one of the old data frames. We talked about how to reassign a whole column using just some list values or a series. We did the same thing with rows using lock, but again, you can use ilock. I would recommend using lock as much as possible. We talked about how to replace all the not and numbers. Then we talked about restructuring. We talked about how to shuffle columns, add in a new column with a bunch of not and numbers, reassign column labels, and then the exact same thing with rows. Okay, so next topic we'll deal with data frame operations. We can talk about arithmetic operations, a bunch of transform operations, stuff like that. So stay tuned for that. Thanks for watching and see you guys in the next one.